Okay, a couple hours into it, quick update. This is where we're at. We've got valve cover off. I took it off just to show you what it looks like underneath there. I'm going to lay it back into place until I finish disassembling everything, just to protect the engine components. The longer you have exposed, the more dust and dirt you get in, and you don't want that. This is that device I was talking about. I think earlier I said it was on the exhaust cam. It's not. It's on the intake cam. I got exhaust valve on the brain, so that's faux pas on my part. But the idea here is that this device allows the intake camshaft to change timing based on demand. A more advanced engine runs more efficiently, but you cannot leave it advanced because it will not idle. So the idea is that as demand increases, the solenoid valve down here opens and allows oil pressure to force the camshaft to change, and therefore becomes a variable valve timing engine. And then it drops back to base timing at idle so that it will idle okay. This is the intake side of the engine. This face on the head mates up with this side of the intake manifold. This is what's called a lower intake, and then there's a plenum that fits out here, a plastic box, which I'll show you in a second. Interesting thing here, this is the fuel rail. The fuel comes in here and disperses into the engine through these four fuel injectors here, the nozzles of which are right here. The idea is for this thing to produce a spray at a given time in the combustion cycle, and by controlling how much fuel goes in, it allows the engine management system to adjust the fuel mixture constantly, along with the cam timing and the spark timing, to create the most horsepower possible for the amount of fuel being used. This side bolts to the plenum, which is a plastic box which is over here. This is the air box. This is where the air filter lives. This is a device called a mass airflow sensor that tells the engine how much air is coming in. But back to this intake plenum. You can see the way that this is designed. It's kind of got a box here. The air comes in here, and the idea is to whip it up and create a vortex so that when the air, this side mates to the intake I showed you, when the air comes in here through the throttle body, it atomizes the fuel better upon impact with the spray as it goes into the engine. Twisting air mixes fuel better than air moving straight in. The throttle body fits in between the air box and the plenum, and that is this device right here. Throttle body hooks to your throttle cables. One of these goes with the cruise control servo. The other one goes across there to the throttle pedal. This is the outside. This lays right here basically. When you step on your throttle pedal, it opens this valve, which lets the air in, and basically this takes the place of the carburetor as far as controlling airflow. Where this differs from a carburetor is that it doesn't have any fuel control. The fuel control is all done by the engine management system and the fuel injectors, which are in the lower intake. Okay, so as far as the engine goes, I'll lay the valve cover back into place. I got to take the exhaust manifold off the back. That's this device. I have to take the side cover, actually the front cover of the engine off. In this car it's on the side because it's a front wheel drive. And then I have to remove the timing chain. I'll have to remove this cam carrier, take the camshafts off, and then I'll be able to get at the head bolts that hold the cylinder head down. The head will come off, and that'll be ready to go to the machine shop in the morning. One side note, two side notes. I found a mouse nest in here. This is actually pretty common, and a lot of times when a vehicle comes in with a drivability problem, we will look for this sort of thing, and if we find that, then we'll start looking for chewed wires, because that'll create all kinds of trouble. This one's been here for a while. They didn't cause any damage. They just decided to spend the night and stole some insulation from the firewall. The other thing that's kind of interesting is this strut support rod that goes across the engine compartment. This is a component that the tuners add into their cars. You'll see these on a lot of Subarus and Hondas that have been hopped up. The idea is to stiffen the top of the body by reducing the amount of flex when the vehicle goes into a hard turn. It makes the vehicle more stable. In this case here, Honda put this in, and what they did was they added a step to it. They tied it into the firewall with two bolts, one here and one here. What that does is it adds an additional layer of protection in the event of a front end collision. This rod will take the forward impact, and instead of allowing it to just fold straight into the engine or into the passenger compartment and into the firewall, it will force a lot of it outward into this strut tower, which will take the force of the impact sideways and redirect it. It's a really good example of how a couple of dollars worth of metal can make a huge difference in the way a car crashes. This is a huge safety factor for this vehicle. Left out would change dramatically how this car would respond in a head-on collision. So that's where we're at. I'll update you in a couple hours when the cylinder head's on the floor.